Exercise 59, page 115, question number 3. This particular function is relating the pressure in atmospheric pressure with height. So the two variables are atmospheric pressure and height. And then you've got two constants. P0 will be the pressure at the start at ground level, P0, and that's given as 1.012 times 10 to the 5 pascals. And C is a constant, which in this particular example is 71,500. So we need to decide on which variable we're going to call X and which Y. Well, again, we're interested in pressure as height varies. So height is going to be my X, and pressure is going to be my Y, which I put into autograph. Sometimes this standard form way of writing a number is a bit of a problem for autograph, so I would always write it in as a number. So what would I type into autograph? I type in Y equals 101,200, which is what 1.012 times 10 to the 5 is, e to the minus, and then I put in the bracket x over 71,500. You could put the minus inside the bracket as well. So that's what I'm going to type into autograph, and then I'm going to play around with the function and see if I can get it to appear on the graph paper, and then use that to find the pressure when the height is 1,420 meters. So let's have a go. So start up autograph, enter an equation, y equals 101,200 e to the power minus x divided by, we use a slash for divided by 71,500. Those brackets. Okay. Not surprisingly, we don't see anything because it's cutting the y-axis at 101,000, so I need to zoom right out on this graph. We'll keep hitting the zoom out button until we see the graph appear. There we go. It's around about the 100,000 mark. The graph is cutting the y-axis as we expected. We've got to find the pressure when the height is 1,420 meters. So this is 100,000, so we've got to zoom right in on this x-axis. So it's about using autograph to do this. If I zoom in on this x-axis to get the 1,420 to occur, there's the 2,000, so 1,000 is going to be around about here somewhere. But we can see that the pressure is not changing. It's a very small intervals over which the pressure is changing. So we can zoom in on the y-axis at this point here to open out the graph. So now we can see that we've got a graph where we can get the pressure at about 1,450 meters, 420 meters. So I can zoom in, that's the 1,000, so I can zoom in on this particular part of the graph to get my value. 1,420 will be about here somewhere, and so we can now end up with a value from the graph.